Okay. Okay. Thanks for coming, and I made it. Very nice. Should I? Well, anyway. Right, so let's continue our lecture. Yesterday, we officially entered chapter 5, right? Chapter 5 is really difficult. Okay. The reason why we're going to talk about chapter 5 is that we're going to understand or determine the stress in the material that subjected to bending. Okay. So, and the first thing I want to tell you is that we have coordinates. The coordinate is really important. Sometimes you need your imagination. Okay, you can see that sometimes we will focus on the side view and the cross section view. Okay, so you need to identify the surface that you see. Okay, so for example, this is a side view, X and Y plan. Okay, and then if you see the cross-section view, you will see Y up and Z to the left. Okay, and then all the shape of the cross-section is symmetry, and you see all the loading is in XY plane. And because of the loading, you will see the deflection curve of the band of the beam or of the material. To describe this curve, we need to use curvature or radius of curvature to determine to see how it bends. Okay, and then we talk about when a material subjected to a positive moment. Okay, positive moment, and upper part will have a shorter length, and the lower part will have longer length. Okay, so which means that there must be a place that in the middle, well, not middle, actually, in between. Okay, in between, that there's no change in length before and after positive moment, right? So we call that neutral axis. And if we set that as an axis for the X, all right, and then we want to see that the section in this material and higher than the axis about Y distant. Okay, so you can imagine that the EF is actually the line we focused, and also it is above the axis for Y. So you can see this is coordinates. Okay, Y coordinates. So EF beforehand it is dx. After the bending, it becomes L1. Okay, so the change of the length will be L1 minus dx. Okay, you can know that. Now, how to determine L1? You can using the radius of curvature, pink pizza. Okay, pink pizza, and then you can write down the pink pizza is low minus y, okay, times d theta, and dx is low d theta. You can see the green pizza. Okay, so by substitute the d theta by using this relationship, you can make L1 simpler, dx minus y over f low times dx. Okay, and because this is L1, right? So you need to, if you want to see the shortened length, you need to minus dx, cancel, and the thing it left is this one. All right. So the change of the EF is this. Divide by the original length, dx. It will become epsilon x minus y divided by log. Okay? And log inverse will be kappa. Okay? So epsilon x equal to minus kappa y. Right. Okay. So again, we focus on positive moment at here, right? So it gives us a smiling curve. But if you are subjected to the minus moment, don't worry. Everything just multiply minus sign. Okay, so should be okay. Now, very quick things that we can help you to know the curvature. So there's a AB beam, okay, and it needs us to determine is that epsilon on the bottom. On the bottom, what is epsilon on the bottom? Okay, so I need to make it epsilon on the bottom. So you can say on the bottom. Okay, and this is epsilon equal to 0.00125. And you will see that the distance it tells us here the distance from the bottom surface to the neutral. Oh, sorry, neutral, not nature. Neutral axis is 150 millimeter. Okay, so here we should go for 150 millimeter. Okay. So neutral axis to the surface, bottom surface, is 150 millimeter, and the couple is M0, right? L and H is 300 millimeter. Okay. Now find radius, curvature, and deflection of beam. Deflection of beam is that you see the middle part of the deflection. Okay, from original point to the end point after the deformation. All right, so yeah, let's continue. Here, it's 1, okay? Log equal to minus y divided by epsilon x, right? We just changed the order of the equation we just made. So now, minus 0.00125. And okay, we need to be careful. The y here is the coordinate, right? So because it is bottom surface, which is bottom surface. So you need to give it as a minus sign here. Okay? You need to be really careful about this. Remember that the y has sign. You see, previously, your y here is positive, right? So your positive y will make it negative epsilon. So which means that it will shortening. But if you go below the neutral axis, it becomes negative. Y become negative. So negative y times negative. So you will have positive x epsilon x, which means that you have lengthening bottom. Okay, so the y has sign, so you need to be careful. Okay, So y has sign. As long as your y above the neutral axis, it will be positive. Below the neutral axis will be negative. All right. So it will give you 120 meter. Wow. So this curvature will become 120 meter. Very long. Okay, very big circle. Second, what is a curvature? Curvature is really easy. Kappa, which is 1 over log, so 0.00833 m minus 1. Okay, you see the kappa is actually has the unit like meter minus 1. All right, so next, what is the deflection of the beam? The deflection of the beam will be this one, right? So we need to use the this shape this triangle, which is a 90-degree triangle, and you know that O1 to the original length. Okay, so you see the yellow one, and which is log cosine theta. Okay, log cosine theta. So you will see there's a theta as a triangle here. So we can say sine theta equal to L divided by 2 and divide by log. Okay, so you will have 4.9 divided by 2 and then 120, 0.02. So again, theta is small. So our sine theta will approximately equal to theta, and which is equal to 0.02 radians. Okay, or you can say 1.146 degree. So your delta will be equal to log minus log cosine theta. What is that? What is log cosine theta? The green highlight length. Okay, so you will have 24 millimeter. Okay, so you will see kind of 24 millimeter downward for the deflection. This example is not really important, but it can tell you that the concept of the y has the sign. Y has the sign, positive or negative. Positive above the neutral axis. Negative means below the neutral axis. All right. So now we sort of understand the bending and the epsilon x, the strain along x direction. Okay. Next, we are going to introduce. We need to change we need to change our view, okay, into cross-section area.你知道我有一个群组是我的国中同学吧，当然大家都现在已经就是职业的人了吧，就是 professional 这样子。然后我们常常在里面抱怨，就是我们的工作上遇到一些鸟事这样。那大家觉得我可以报告什么鸟事呢？其实就是，当然我觉得那些鸟事是很好笑的，我就跟他分享，跟大家分享。其实我这边负责的，就当一个老师，我负责的地方就是，我有一个 hashtag 叫做100种不能犯的 email 的错误，就是 我这11年来收到超多神奇的 email，非常非常的有趣。那例如说，有人要找我来念博士班，然后他就写信，那个标题啊写好了，然后就写 Dear 周老师，皱纹的皱，周老师，然后好好，然后就写，然后他就当然下面写正常啊，这是第一种。第二种就是 Dear 年老师啊，这是第二种。第三种就是老你好，他就只写老，然后你好，老你好冒号，然后就开始写，然后写什么的很多哦。然后最近我遇到一个也是要找我念博士班，然后他的 email，我就让手机打开来看，他就只有标题啊，关于博士班请益，然后下面就黑的，然后我想说，哎，是还没有 loading 好吗？然后我就这样子等他一下，没事，然后就把那个 app 往上滑掉，再重 load 一次，哎，还是黑的。然后我想说，这个人写了一封黑的信，哎，这是我不好意思，我是那个 dark mode，然后就是深色的模式。我说，哎，怎么都白的，什么都没有东西，好奇怪。然后我就就是想说，好，算了，我就不念了，我就去做别的事情。然后等到结束，就是过了一阵子，想说好，手机应该正常，或者网络有正常，然后打开来再看，还是黑的，就都没有，就只有标题，下面都是空白的。然后我想说，这个难道是用标题写 email 方法吗？就是有些人真的是这样的，有些学生就是标题写完以后，中间都没内文是没有，把它当标题当讯息在传，这样，这也是其中一种。但是已经很久没有遇到了，我想说这个博士生要就是也蛮大的。结果后来我发现这个是我最近看到的，蛮有趣的，我就不知道手贱，我就忽然这样一下，我就发现它是可以往下滑的，然后我就开始哇，超长的空白，我就一直往上滑。你记不记得 iPhone 刚出来的时候？我不知道那时候大家还几岁了，但是有一个叫做滑卫生纸的那个 App，然后我就开始滑，一直滑，然后就发现那旁边那个有一个叫什么那个 Score Bar，对不对？很小，然后我就开始狂滑，滑，终于在最下面的时候找到他的讯息了。他在下面就啊，那周老师好，这样子。讯息是正常的，讯息本身是正常的，但是我为了要看那个讯息，开始在那边滑超久。对，就这样，我可不可以给你看到？但我不能让你知道这人是谁，但我只觉得超好笑的。嗯，好，等一下再看好了，有空再看。对我就觉得蛮好笑的，就是第一次看到这个，然后我就分享这个给大家看，然后大家就觉得哇，这个超神的，他到底按了几个 Enter 啊？好，讲完了，下一页。翻译吗？English. I just received a really interesting email from students, and the email need me to scroll down like 100 times to reach the text. I thought it was unloaded. Okay, I just wait for loading, but turns out I need to swipe like 100 times to get the main text. All right, so let's continue. Next one, I would like to invite you to discuss cross-sectional area properties, centroid, and moment of inertia. Right, moment of inertia. I guess you remember that, right? Moment of inertia is the properties that tell you how difficult a material can be rotated, right? In this case, how difficult of the material be bend. Bend and rotate are similar. Okay, so I guess you understand this. So first moment of area. We need to introduce the cross-sectional area property. The first one is centroid, 行星, and the other is moment of inertia. Actually, this one is first order, first moment of inertia. And the second one is the second order. All right, so you can see that. Right, so what is the first moment of inertia? The first moment of sorry, no inertia. First moment of area. Okay, so the first moment of area is actually tell you how this area distributed in the space. What is distributed? Scattered. OK， 分散在这个空间里面，它是怎么样分散在这个空间里面的 ？How it distributed. Okay, so the distribution of a shape area relative to an axis. Of course, when you define a space, you need to define axis coordinates, and then you can do all the calculation. So actually, the coordinates can be randomly chose, randomly moved. You can choose this, you can choose this, you can choose that, you can even choose this. But well, sometimes, yeah, so we just choose a proper coordinates. All right, so the distribution of shape of area relative to an axis of, if we choose xy like this, and there is an area potato like this. All right, so we need to see that, you can see that all the point, or you can say the A, small area has x, comma, y as a coordination, right? So we want to see this dA, how it plays here and relative to certain axes. For example, qy means that the area related to this axis, OK， 相对这个 area 这个面积相对于这个 y 轴，它怎么样分布的 ？So the easiest thing is that the distance, right? So this area with this distance, that area has that distance, that area has that distance. We need to sum them up. We need to integrate it, all the area. So you see the A times the X, the A times the X. All right, so you can see this is describing how area corresponding to y-axis, this one. All right, and the other is that if QX means that the area corresponding to relative to the x-axis by y coordinates, right? So their distance will be y. So this area y, this area another y, and this area another y. Okay, so you need to sum them now, all the small dA times its own y, and then do the integration. So you can see that the area of this potato and times its own height, y. So after you sum out all of them, and then if you divide by the area, so you can see that this is all the area averagely distant to the x. So that's the centroid distance. 听懂吗？就是每一个小面积有它的 y， 每一个小面积有它的 y， 每一个小面积有它的 y。OK， 全部加总起来，再除以它的面积，总面积，那不就是这一个面积平均来说对于这个轴的距离吗？那不就是行星的定义吗？对不对？Okay, that's the definition of the centroid of the shape. Right. So you can see x bar and y bar. Okay, means that the average distance to the y-axis of this shape. So it's the XdA integration divided by dA integration. dA integration means total area. Okay, so this is X bar, and Y has yeah, just similarly. Okay, so if I guess you can understand this. This is kind of an easy concept you can understand, but I will inform you one thing. If the X and Y axis are chosen, okay, chosen right at the centroid of the shape. Q, Y, and QX equal to 0. This is really important, okay? So you can imagine that if the XY and the origin is not at the centroid, for example, in this case, all the Y and all X are all positive, right? So when they sum down together and divide by A, you will have a positive distance, okay? Positive distance, positive X, positive Y. But if you choose your XY to here, so some point will has positive X, but some point may have minus X, right? And some point may have positive Y, but some point may have negative Y. So you can imagine that after that, if you choose the XY axis at the centroid, all these things will cancel each other. Okay, if you locate at that centroid, so QX and QY will equal to 0. Okay, so the QX and QY actually, or you can say bar X, bar Y, okay, they will greatly, significantly affect by the way you choose the coordinate， 听得懂吗？哈，就是如果你今天选在你的坐标选在这个截面的行星上的话，它的 QX、QY 就会等于0哦，就会等于0。为什么？因为它每一个面积都有自己的 X 跟自己的 Y 嘛，但是在右上角第一象限的它就是 X 是正的，但是如果你在第二象限的 X 就是负的，所以如果你正好坐落在中间的时候，他们就互相不是坐落在中间，坐落在行星上的话，他们在积分的时候就会互相抵消掉，它就会得到0。OK， 其实我们可以想象，就是这个 bar X 跟 bar Y 就是你的原点跟它的行星的距离啦，就是这样的。OK，so this bar X and bar Y is actually the distance, the relative position for centroid and the origin you choose. So if the origin overlap to your centroid, of course, bar X and bar Y equal to 0. All right. Next, centroid of combined areas. Okay. So if you understand the integration things, you actually can refer this as a summation when you see a more regular shape. Okay. Oh, and so you can say all the small area, your X bar will be X times AI and summation together divided by total area. I believe you know that because you learned that before. Okay, please find the position of the centroid C of the section shown in figure. Okay, so you have two areas. So the first one, okay, first one. first area, okay? And you set, oh, you see, you set the origins here. You see 0, well, we should say O, okay? So A here, and we will use green for the second square, okay? Actually, this problem, this example can be solved by ChatGPT. You can try that. I just directly screenshot this and input that, and it will give you, it can solve for you, and like 80% you will get correct answer. Okay, I tried that before. You can try that at home. All right, I gave you the tutor, right? The mechanics tutor. You can try that. Okay, it's fun. A1, 120 times 10. We want to determine the centroid of the L shape. So it is easy that we can determine, we can summon for the x1 for the different part of the shape. So in A1, you know that this is rectangle, right? So you know this is its centroid. Okay, so your centroid is actually 60, and this is 5, right? 5. So your x will be equal to 10 divided by 2, 5, and your y1 is 120, 60. All right, how about A2? A2 is 70 times 10, 700 millimeter square, and your x2, where is it? 70 divided by 2. Don't forget plus 10 to 45. Okay, so you are here, right? But this length will be 40, right? X2, X2, Y2. Okay, so your X2 the coordinate should be 70 divided by 2 and plus 10. Where's 10? Here. So 70 divided by 2, 35, right? 35 plus this length, 10. Okay, so 45, and Y2 will be easy. Y2 is 10 divided by 2 is 5. Okay, so you have green and yellow part. Okay, so how can we get the centroid of all the area? I believe you know that, right? This is really easy. Centroid coordinate. Okay, x bar equal to A1 x1 plus A2 x2 divided by A1 plus A2 y, well, equal to 100, 20 times 5 plus 700 times 45. Okay, 120 plus 700, so 19.7 millimeter. And you can use exactly the same procedure, 39.7 millimeter. Okay, so your C point here will be the coordinate for C is 19.7, 19.7 and 39.7. In my case, if I throw these images to ChatGPT, it gave me a wrong answer when it calculates A2. It calculates 80 times 10. All right, so it result different answer. So don't believe ChatGPT. Okay, don't ask it solve the problem for you. You need to, well, it can guide you to solve this, but you need to go through everything by yourself. All right. So basically, because you understand this simple rectangle, you know the centroid of this simple rectangle. So if you multiply back your A back to x1 and y1, so you will obtain this, okay? So just like the average for maybe two classes, if you know the average for class A and you have your average for class B, if you want to calculate total average of these two combined total classes, you can just determine the class A average times class A students number plus class B average times class B student number and divide by total student numbers, right? So just like this， 听懂吗？就是你已经知道简单的形状的行星在哪里，那你知道这两个是简单行星在哪，那你要怎么样去算出它全部的行星呢？其实就是很简单，就把它的简单的形状的行星乘它自己的面积，然后加总起来再除以总面积就好了。就有点像是你有两个班，你要求两班的平均，但你一开始你只知道 A 班的平均跟 A 班的人数 ，B 班的平均跟 B 班的人数，那很简单啊，你就把 A 班的人数乘上 A 班的平均，加上 B 班的人数乘上 B 班的平均，加总起来再除以它全部两班的总和，就跟这个一模一样的事情。OK， 对，那绕口令哦。Okay, I guess you understand this. Next one, I will give you another way to solve it. It's quite fun. It is quite fun. Because no one say the area must be positive, right? So there, I will give you an alternative way to calculate this. Actually, this L shape can be determined by two areas. The first area is bigger, and the green area has negative area. So A1 equal to 120 times 80, 9600, and X1 equal to 40, Y1 equal to 60, and 2. A2 equal to, okay, minus 110 times 70. That's important because there's nothing there. There's nothing there, but your yellow determined that, you included that. So you need to cancel it. Okay, so your X2 equal to 45 and Y2 equal to 65. So your X bar equal to 9600 times 40 plus minus 7700 times 45. So you need to be careful that if you include something you shouldn't include, you need to minus it. You need to you need to delete it, and you will get exactly the same answer. All right. So it is a really it's really flexible way to solve it. So be aware, area can be negative as long as you use it correctly. All right. You can try that to input those things in ChatGPT. Okay. Right. So I guess this is quite important. Next one is more important. Next one is going to talk about the moment of inertia. Although we talked about that before, so we will just give you a quick review for that. Remember the previously moment of inertia is how difficult you rotate a projection. Okay, so you can see that this is a rectangle projection, and this you need to rotate about, for example, x-axis or y-axis or x bar or y bar. So how difficult we can rotate about this? Remember that these values can be checked in the textbook appendix D. Okay, and remember that the area has the smallest moment of inertia about the central axis. For example, remember that I have showed that before, right? So this is the area you want to rotate or you want to bend. Okay, so you see that the neutral central. Okay, the central axis is here and here, right? So it's easy for this area to rotate like this about this axis, or this axis. Easy, right? But if you using this area, sorry, axis, x and y as an aid, you need to rotate that. It's really difficult, right? It's really difficult. Okay, or you rotate this. You need to rotate this. Very difficult, right? So that's it. And also you can see that easy way about central, it will has smaller value, 1/12 bh cube. Yeah, so, and if you go for the age, you will have 1/3 bh cube. So this is ix and iy is greater than ix prime bar, iy prime bar. The bar means that, and bar and x prime and y prime means it go through the centroid. All right. So I believe I told you before. So just quickly review. Right. So next one is parallel axis theorem. So this section, this cross section, not necessarily rotate about centroid or rotate about age axis. So you need to learn this parallel axis theorem to move your rotation axis. Okay, so the moment of the inertia I bar xx bar of an area about its centroid. Okay, so we know the centroid. We know the centroid. So because we can check in the appendix D, right? So, for example, we want to rotate not green line. We want to rotate this area about the pink line. Okay, so we need the purpose of this page is going to move the green axis to pink axis to determine the first to determine the moment of inertia about the pink axis. OK， 我讲的就是这样哦。你要转的时候，你不一定每次都只转对着这边边转，或是对着它的行星转，不会吧？哈，你在真正的工程应用上，你可能会对其他的轴去转。那这时候我们就必须要使用平行轴定理。我们原本知道橘色不讲错，绿色的可以用查表嘛，哈，查表到某一个形状，我们就可以查说，哦，这个形状它的惯性矩是多少，这个我们知道。那可是我们如果要移到一个粉红色这个地方，随便一个地方，它会变多少呢？这时候就需要平行轴定理。Most important thing is that we can only move from centroid axis to an other arbitrary axis。我们只能从平行轴移动到别的轴，我们不能去乱移哦，我们不能乱移。Okay, so the parallel axis theorem, I bar xx bar. Okay, I will prove that here. Okay, next week, and then you will see that it will increase. It will increase a positive value to get Ixx, new moment of inertia. All right, so I will see you next week. And if you have any question, just come here. Okay. 哎，对哈 ，Thank you very much. I will continue. Thank you. So I can continue. All right. So you notice that the A is a positive. dx squared will be positive. So you will see that if you rotate about the axis, not at the centroid, you only increase the difficulty of movement, rotation, right? Because axis and centroid axis are always the easiest, smallest moment of inertia. Okay, so you move from the smallest to the higher. You will add area and the dx squared. Okay, dx squared. So let's take a look. Let's prove that. Proof. And proof. Okay. So our Ixx, which is a y squared dA. This is definition, right? Equal to a. Right. So you see our Ixx here is actually what we want, right? What is what we want? The axis, the coordinate we set arbitrarily by ourselves. Okay, so Ixx definition is this. So relatively to the x bar and y bar, what's the difference? Let's take a look. Y bar plus dx, okay, square dA. So so you can see that this is the distance, between x bar and x axis. Okay, you see that your y square is actually, if you have previously in the x bar, y bar, this dA has y bar's coordinates, right? But now, because you change to new axis, your y here become this and that. So you need to add one more dx to obtain a new coordinate number. Okay? So if you can get this, we can further write down ay squared dA. So you can see that this part is actually for the x bar, y bar. But now you are going to see the new axis xy. So all the coordinate need to add the differences. Okay? So 就是你原本在看的是行星的坐标，但你现在移到了粉红色的新的 xy 坐标，所以你原本的坐标都要加上它的差距就对了，才会是新的坐标嘛，才会是新的坐标轴。Okay? So if we expand this 2dx a y bar dA plus a dot dx squared. Okay, so we expand this and we can get a longer things. Okay, and we notice that, wow, this is the green part, right? And we notice that our A integration y bar dA is actually equal to 0 because x bar axis through the centroid, right? We just said if the x bar through the centroid, its area integration for y bar will be equal to 0, right? So it can tell us I bar xx plus a dot dx squared. And you know that the previous one is this is actually I bar x bar, all right? So you notice that if you move from here to a new axis, all you need to do, go back to your definition, your y bar needs to plus dx, extra differences, okay, between the two coordinates. And after you expand it, and you find that this actually equals 0. So the thing you left is that if you want to move from green to pink, you need to add area times the differences squared. Okay? So similarly, Iyy equal to Iyy plus a dot dy squared. Okay? That's it. So if I hope you kind of understand this, and I will give you a quick example to apply the parallel axis theorem. Okay, remember that we have a rectangle, right? And this is x, this is y, and you have your axis through the centroid, axis through the centroid, right? And this is C, and this is B, and this is H, right? And you know that I bar XX bar equal to BH3 divided by 12, right? You can check in the previous page, right? So which means that this axis is BH3 divided by 12. Let's do about this, right? How about the H1? The H1. What is H1? Equal to what? So all we need to do is do the parallels axis theorem. BH area, right, times the difference between the two square. Okay? Sorry. Okay? What will we achieve? Equal to BH3 12 plus BH3 over 4 equal to BH3 3. Okay? Did you notice that? You learned that before, right? If you move from a centroid axis to an edge, you just add out area times the half edge square, and you can get this. See? Right? So that's how we determine the edge. Okay? And then you know that if you move away from the central axis, you will always get a higher I. Okay? So I guess I need to finish. So thank you for today. And I will, yeah, if you have any questions, just come here. All right? Thank you. Bye. 今天话还好，但是以后应该会。那我想问，哎，等一下，我先 stop recording.